Hey there, how you doing? Are you stressed and don't know what to do? Tired of reading your boring textbook? And also, are you tired of boring lecturers at your school? Here is your one-stop destination to sort out all your problems. Smart Book NEET series brings some amazing and quality content for all the NEET aspirants out there. This YouTube channel is very beneficial for all the biology, science students out there. Now, learning becomes easier. Stay at your comfort zone and listen to our daily interactive online sessions for absolutely free of cost. So, why should you choose SmartBook as your option? We provide quality video lectures through our modern qualified teachers with some amazing presentations. We've doubt clearing sessions, quiz sessions, daily practice problem sessions, etc. We also provide PDF for every lecture so that it will be useful for your future reference. So, why late? Subscribe to SmartBook NEET.
Hello guys, how are you doing? Hope you are doing great. So today in this video, we are going to start amazing session on physics chapter 1, that is units and dimensions. It's a very important chapter because it's a basic fundamental chapter. It's regarding your previous classes, that is 8th, 9th and 10th. Based on those syllabus, this chapter is designed right now. So before going to start this video, make sure subscribe and tap the bell icon to get instant updates of our channel. Okay, so welcome to our SmartBook YouTube channel, Behatareen platform, and we have started this amazing NEET series for all the NEET aspirants out there. So let's get started. Our first chapter is units and dimensions, and it's a first chapter in physics based on the NCERT. Okay, so we have created amazing Telegram group. As you can see here, this is the Telegram app, as you can see. So we have started this amazing Telegram group so that you can join through the link in the description provided below the video. There is a description box where you can go and join through the link over there. Okay, why do you need to join our Telegram group? Because we provide instant updates regarding our NEET syllabus and any other kind of related information, and we'll be posting some of the important PDFs and amazing sessions like this, and DPPs, practice problems and all. We will be posting that in our SmartBook NEET group so that you can achieve more knowledge, and it's a pathway to reach your NEET success goal. Okay, so how do you join our Telegram group? Download Telegram group and register, and go through the link in the description box, click on join the group, invite your friends to join the group. You can see I'll be providing this entire session PDF so that you don't need to make any notes. Okay, so I'll be providing this entire session PDF in the description box. Okay, we'll be providing our Telegram group link in the description. We'll be providing the PDF link, and we'll be providing our Instagram account so that you can ask your personal questions or queries, or you can mail us at smartbookcommunity@gmail.com, where you can ask your queries, and you can send in the form of any JPEG or PNG or any kind of PDF form, so that you will be featured in our upcoming videos. So I'll be providing DPPs daily, which means daily practice problems, and you have to solve them, and you can send me via Gmail in the form of pics or in the form of PDF, no matter what. So make sure send those, and I'll be awarding or rewarding the names in my upcoming videos. So do you want the chance? Make sure do that. Okay, I'll be providing DPPs at the end of the session, so stay tuned. So why do we need units? For reliability, accuracy, to minimize confusion. Why do we get confusion? For example, if you go to a market, so you have gone to an vegetable store or a fruit store, and you have asked to give some 3 kg of melons or lemons or mangoes or apple. So let me take for example mango. So you go to shopkeeper and ask, give me 3 kgs of mango. What is this kg? Kg is a unit and the 3 is a numerical unit. So these two forms a physical quantity. So if you go to shopkeeper and ask him, give me 3 mangoes, 3 does it mean 3 mangoes or any other unit? You have to specify some unit over there. So that's why, for reliability, for accuracy, and to minimize confusion, we need units. So it might be very silly for you, but you have to concentrate in this lecture because it's a very basic fundamental chapter in which you're going to build a foundation for your NEET syllabus. Okay, and provides reference point by which objects of length or volume can be described. It provides a reference points, like in the form of if you want to calculate area of a solid or a volume of a solid, you need some of the reference point, and those reference points can be given by the units, based on the units. So 3 centimeter cube, which is the volume, 3 centimeter square, it's a unit of area, like that you have to know. So there are several kinds of units. We will be discussing about it in upcoming slides. Okay, so why are units so important? To minimize the confusion, we need units. So units, why are so important? So as you can see here, there is a Vernier scale. It is also called as Vernier calipers. So what is this Vernier calipers? So it is used to calculate the diameters of the internal and external of a large solids or anything, and diameters also, so that to for the higher accuracy and to avoid the human mistakes, human errors. So we do some of the little errors while doing that. So this Vernier scale, or called Vernier calipers, this is used to avoid the human error or misconceptions. So it's like a compass, as you can see. It consists of internal jaws, external jaws, locking screw, imperial scale, metric scale, depth measuring blade. So these are some of the important parts of a Vernier scale. Make sure take a look at it. So let's understand why units are necessary. So as you can see here, there is a chart over here based on the heights of each and every person. So when you see this small dwarf person, his height is increasing, like progressive increase. Okay, so here it is 2 units, and this woman is 5 units, and she is like 5.5, and he is like near to 6, 5.5 or near to 6, and he is very tall. So his exceeded 8.5. What are these? It may be in the form of centimeter, it may be in the form of meter, it may be in the form of feet. So if we didn't mention anything like centimeter or meter or any, if we didn't mention any unit and we have mentioned only numbers, what does it mean? It doesn't make any sense, right? So that's why units are very important in our daily life situations. If you go to a store, or if you want to check your heights, and in everyday situation we use math and we need those units. Okay, so there are 2 types of physical quantity. There are non-physical quantity and the physical quantity. What is this physical quantity? The quantities which cannot be measured by an instrument is known as non-physical quantity. It doesn't require any instrument to measure. Like for example, if you take a like for example, you didn't mention anything like area or length or width or height, you didn't mention anything, but if you mention school, car, bus, building, it doesn't make any sense. It doesn't require any measurement. It's like a space. So we didn't mention area of the building, or we didn't mention area of the cardboard, we didn't mention area of the blackboard. So that's why it's a non-physical quantity. If you mention anything extra information like area, length, and any surface area or any kind of math related concepts, so that's why physical quantities used. Physical quantities are the one which are measured by an instrument. It's very important, and by means of which we can describe the laws of physics. For example, length, velocity, acceleration, force, time, pressure. So physical quantity is of length, velocity, and this velocity, acceleration are of derived physical quantities, whereas length is a a normal quantity. It's a fundamental physical quantity, and these are the derived from those: velocity, acceleration, time, force, pressure. These are of derived quantities, which means they are derived from the fundamental or base physical quantities. We'll be learning about the types of physical quantity and the units. Okay, so what is this physical quantity? Physical quantity is generally termed as numerical value into standard. What is this numerical value? It is denoted with the letter N, and it is standard. What is the standard? Standard is a unit. N into U. Q is equal to N into U. It's a very important term, and you have to remember here Q is constant. For example, if you go to shopkeeper and ask him 1 kg of mangoes, and he would give you with the price, okay, and you go and ask 1000 grams of mangoes, it gives the same quantity, which means you have just changed the number and their units. Like that, if we change the number and also units, it doesn't make any sense with the quantity. Quantity is always constant irrespective of their numerical value and the units. International accepted reference standard is generally termed as unit. That unit should be internationally recognized. Okay, so unit. What is unit? Measurement of any physical quantity involves comparison with a certain basic arbitrarily chosen internationally accepted reference standard is called unit. Okay, so these types of units: fundamental or base units, derived units, supplementary units. We'll be discussing about it right now. So fundamental or base units, these includes like current, amount of substance, temperature, length, mass. As you can see the picture over here you can see it's a unit for time, kg for mass, mole for amount of substance, candela for luminous intensity, K for temperature, A for electrical current, M for mass, so that you can learn about it. These are the fundamental or base units. These are the elementary quantities which covers the entire span of physics. There are only 1, 2, 3, 4, 5, 6, 7. There are only 7 fundamental physical quantities, whereas there are thousands of derived quantities which have derived from these fundamental or base quantities. These are very important, and these 5 are very important terms. From these we can derive those derived physical quantities. These are independent of each other. Any other quantity can be derived from this. Okay, so what are these fundamental or base quantities? I've told you length, time, like that. Okay, length, meter, m. So in dimension, the form of dimension, it is denoted like this: m. Sorry, length is with L, mass M, time T, and this is electric current is in the form of A, and this is in the form of temperature in the form of theta, which is a degree, and amount of substance, mole, and this is candela in the form of dimensions. And we'll be learning how to know the dimensions, how to make those dimensions from a formula. From any derived quantity we can make a dimension out of it, and I'll be telling you about the tips and tricks and the concept of dimensions in my upcoming lectures of this lesson. Okay, so for that, make sure subscribe to our channel. Okay, derived units of all other physical quantities can be expressed as combinations of base units. Okay, these are the combinations of fundamental or base units because they are derived from fundamental or base units. Such units obtained from the derived quantities are called derived units. Okay, so what are the? Area, volume, density, velocity, acceleration, work, power, energy. There are a lot of kind of stuff. Okay, areas length into width, volume length into breadth into height in cuboid, density mass by volume, distance by time, speed also comes into play here. Okay, so they are derived. So how can we say they are derived? See, length is a fundamental or base physical quantity, and the width is also a form of length, so it's also a fundamental or base physical quantity. In volume also, it's also length. Width is also kind of length. Height is also kind of length. Mass we have this mass is a fundamental quantity, okay. And volume it is also, volume is of three lengths, length into length into length, or length into breadth into height. If you take anything, all the three comes into the same category, that is length. So length is a fundamental quantity, that's why they are called as derived. If you see acceleration, velocity is displacement by time. Displacement is a fundamental quantity, time is a fundamental quantity by time, okay. And work is equal to force into displacement. What is this force? Force is mass into acceleration. Mass is a fundamental quantity. Acceleration is a derived quantity. What is acceleration? Velocity by time. Velocity displacement by time. Displacement time by time. So they are fundamental quantities, and we have derived from the fundamental quantities. Did you understand? Okay, there are supplementary units other than, sorry, I have to mention supplementary, okay. Yeah, so what are the supplementary units? Supplementary units are the units that are other than the fundamental and derived quantities. They are special because this contains the angle based on the dimension wise. So there are two kinds of dimension under this chapter. There are 2D and the 3D. There is also 1D, but under this chapter we are going to consider 2D and the 3D. And plane angle is based upon 2D, 2 dimension. Solid angle is based upon the 3 dimension, okay. These 3 dimensions include length, breadth and height, whereas in plane angle it takes only length and the breadth or width, or length and height, or length or width, or like that, any kind of alternative. So plane angle unit is radian. It's denoted with the letter R. And what is the unit for solid angle? Solid angle unit is steradian and is denoted with the SR. Very important terms. So let us take the look at the examples. What are these examples? Calculate the angle of 1 degree. So we know that arc by radius. So let us take 360 degrees in a circle. In a total, there is a total of 360 degrees. We know that. And the arc, here arc is the perimeter of the circle, because we are going to consider total circle. 2 pi r, and we know the formula by r, okay. R gets cancelled. 360 is equal to 2 pi. So what we're gonna do, we need 1 degree, 360 degrees. So divide 360 on each side, okay. What we're gonna get, 1 degree is equal to pi by 180. We have pi by 180, okay. Pi by 180, it's not degree, it's radians. What is the unit of plane angle? Radians. In a similar way, you can calculate for 1 minute and 1 second. Let me give you a hint for you, and make sure answer that in the comment box. 1 minute, we know that 1 minute is equal to 60 seconds. What about 1 second is equal to 1 by 60 minutes? And we know that 1 degree is equal to 60 minutes. What about 1 minute? 1 minute is equal to 1 by 60 degrees. Like that, calculate for 1 minute and 1 second. For 1 minute, it's a formula, and for the 1 second, it's a formula 1 by 60 minutes, and you're gonna convert this 60 minutes into degrees again, and you're gonna calculate the radians like this. You're gonna divide by each side or multiply by each side to get the final answer. So it's a task for you. I have done the first one, so I'll be leaving this entire session PDF given below in the description box. You can go there and check out the problems I've given, and make sure to do that and comment down below, or mail me to smartbookcommunity@gmail.com. okay. So we have 360 degrees is equal to 2 pi. So what about 1 degree? It forms 1.745 into 10 power minus 2. 1.745 into 10 power minus 2 radians. And what about 1 degree? 1 degree is equal to 60 minutes. What about 1 minute? 1 minute is equal to 1 by 60 degrees. And we're going to convert those values, and we get 2.908 into 10 power minus 4 radians. Okay, and 1 second is equal to 1 by 60 minutes, and 1 by 60 minutes we're going to convert into degrees and then into radians, and we get 4.847 into 10 power minus 6 radians. There is no need of remembering these values. Okay. So solid angle. So what is the solid angle? Let us take a look. D ohm. It's called ohm. You might have learned this in your electric current chapter in class 10 or 9. It is unit of resistance. So what is the unit of specific resistance? Ohm meter. Did you get? Okay. Why do you need to discuss about that right now? Let us concentrate here. This one is equal to dA by R square. dA by R square. D ohms is equal to dA by R square. It's a formula. What is this ohm here? Ohm here is an angle. It's a ratio of intercepted area dA of the spherical surface described about the apex over the center to the square of its radius R. So it's very simple. It is equal to area by R square. Very simple. Area by R square. Very simple. So plane angle actually has 2D dimension, right? 2D dimension consists of only single values. There is no square. Whereas in solid angle, we have area and the radius. We have squared them because it's a 3-dimensional one. So that we have got those values. It's a very important formula. Make sure take a note or take a screenshot or check the PDF. So calculate the solid angle subtended by an octant of a sphere at the radius, at the center of the sphere. What is this octant of a sphere? Octant of a sphere is nothing but 1 by 8 of a square. What is the area of a square? Area of square is nothing but 4 pi r square, and we have know the formula by r square. What is the formula? A by r square. We have noted down the area, and they have mentioned octant of a sphere, which means 1 by 8, and we are going to cancel those. Pi by 2. Pi by 2 is the answer. Pi by 2. We have got, it's very simple. You have to remember those formulas and substitute them with the given values. Very simple. Don't feel physics is difficult. It's very easy. Okay. International system of units. We have CGS, MKS, FPS, and the SI units. CGS, centimeter, gram, second. MKS, meter, kilogram, second. Foot, pound, second. FPS. SI is generally known as standard. Something there is a, I don't remember it correctly. Make sure comment down below what is the full form of SI unit. It's basically like standard or something, and it was recommended by General Conference on Weights and Measures in by year 1971. Very important. They might ask you who recommended SI unit. So it's followed all over the world. Many of the countries don't follow CGS, MKS, and FPS right now, but they follow SI units. It's very important. And nowadays, nowadays many of the formulas are based on the SI units itself, and they're gonna give you those values in the form of CGS or SI, and they don't go with MKS and FPS. They only go with CGS and SI units. So measurement of length, it's not a very important slide, but take a look at it. Okay, meter is the length of the path traveled by the light in vacuum during a time of interval of 1 by 299,792,458 of a second. In the year 1983, it was told that meter is the length of the path. Meter is a unit, right? It is the length of the path traveled by the light. It's a length of the path. How much distance does the light travel during a time interval of that exact particular interval that I've told, 1 by 299,792,458 of a second. In a second, there are a lot of several milliseconds, microseconds, like that. It's like 1 by 299,472,458 of a second, and it was told in the year 1983. This number is not very important, but take a look at it. Okay. So measurement of large distances. How we gonna measure large distances? Like for example, if you are standing here and there is a star over here, over there, and how we gonna measure that? It's only through parallax angle. Parallax angle fixes or resolves this issue. Parallax method. Large distances such as distance of a planet or a star from the earth cannot be measured directly from with a meter scale, right? We cannot take a very long meter scale and measure over there, right? It's impossible. And don't say that I'm impossible. No, don't say that silly reasons in physics class, okay? An important method in such cases is parallax method. It's like a parallax method, as you can see here. Here the star mark, it's an angle, right? It's here, it's a yellow mark. This is called parallax angle to view large or long distances. Like it's used in astronomy, physics, and astrophysics, and this parallax angle is very much used in astronomy, okay? Astronomy. Example, a man wishes to estimate the distance of a nearby tower from him. Okay, he want to estimate the distance of a nearby tower from him. Okay, he stands at a point A. Okay, he stands at a point A and in front of the tower C. And in front of a tower C, and spots the distance of a very distant object O with the line AC. Here is the object O, and he then walks perpendicular AC up to B. Here is a perpendicular AC up to B. My diagrams are very bad. I'm very bad at diagrams, but please adjust, okay? So it's B, okay? Perpendicular distance to AC up to B, and then a distance of 100 meters. He takes a look at O and C. The line of sight is of C. The line of sight of C is shifted from the original line. It's the original line. It's shifted from the original by an angle of 40 degrees. So here is a theta, and here also becomes a theta. Here theta is equal to 40 degrees. And what is the distance measured? Perpendicular to AC up to B, distance of 100 meters. Distance of AB is 100 meters, and we have to estimate the distance of the tower C from original position A. We have to find AC or AC. We have to find. So we're going to use a trigonometric ratio like tan theta. We know that tan theta is equal to opposite by adjacent. What is the opposite to theta over here? Opposite to theta is 100 by we don't know the adjacent value. We need to find that itself, right? 100 by distance or AC. Tan 40. So D is equal to 100 by tan 40. So here is a solution for you. And also I have also made a detailed picture because my handwriting is very ugly, right? So that's why I have made this picture over here using MS Paint. Okay, check the diagram. In triangle ABC, angle C is equal to 40 degrees, and using trigonometric ratio tan theta is equal to 100 by AC. Opposite by adjacent, theta is equal to 40 degrees, AC is equal to 100 by tan 40 degrees. We have got the answer finally. That's what I have done over here. Okay, so here is a daily practice problems for you. The moon is observed from two diametrically opposite points A and B. Here is the moon, and there is a diametrical opposite points A and B. The angle theta is subtended at the moon by the two directions of the observation 2 degrees. So don't worry, this means 2 degrees. Given the diameter of the earth to be about 3.14 into 10 power 7 meters, compute the distance of the moon from the earth. So you're gonna use the parallax method itself. It's very easy. If you know the answer, make sure comment down below, or if you have any doubts, make sure mail me to that email, smartbookcommunity@gmail.com, and I'm gonna give you a detailed solution. Anyway, after 2 or 3 weeks I'll be posting this DPP solutions in my upcoming videos. We'll make a separate series for DPPs also, okay, don't worry. And we also have amazing quiz sessions and all. And here's another question for you. I'll be leaving this entire session PDF in the description box given below so that you can check there. So with this we end this session, and in my upcoming lecture we're going to discuss more about these units and all, and we're going to solve more and more problems in my upcoming lectures. This first chapter consists of total of 5 lectures, and make sure watch all the 5 lectures, and we'll be uploading every week. It's maybe physics or chemistry or biology. For that, make sure subscribe to our channel and tap the bell icon to get instant updates of our channel. And moreover, we have created Telegram group. Don't forget to join our Telegram group and subscribe to Smartbook. Tap the bell icon, get post notifications, like our videos, share our videos, comment down or mail us for any queries. Telegram group will be providing my Telegram ID over there so that you can contact me personally for any guidance you want. Moreover, it's absolutely free. Why are you wasting your time on extra coaching centers and all? So here is Smartbook for you, to one-stop destination. Make sure like, share, comment, and don't forget to tap the bell icon and get instant updates of our channel. Bye bye.